So this is continuing 1.8. And what we have is three functions in front of you, where this is called a rational function. Basically, it's two polynomials written as a ratio. Clever, isn't it? Now, right now, I don't expect you to be able to graph this. You might have learned this in Algebra 2. What I'm concerned about is that you recognize where the domain has an issue at -2 and +2. We have a vertical asymptote here, and we have a hole in the graph right here. Now, I'm not telling you like what your clues are for that. I just want you to recognize that and to be able to identify the domain, because that's what we're doing. So this domain is clearly from -infinity to -2, and then from -2 to 2, and then from 2 to infinity. So before I explain what well, basically down the road, you will not be given the graph. So you need to be able to look at the equation and tell me what the domain is. That's where we're headed. Same thing with the next one. We just change colors. This is a square root function. Square root, pretty clear. So this is correct. It's reflected over the y-axis. It's shifted right 5. And we talked about that earlier in this chapter. And so down the road, what I want you to be able to recognize is what the domain is without looking at the graph. Right now we can look at it and we can tell it's from -infinity to 5 with a bracket. And this third one is actually the easy one because it's a cube root. And the nice thing about cube roots is we can cube root positives and negatives, so the domain on this one's all reals. So if you come across a cube root problem, it's very easy to state the domain. So if we were to ask some of these questions, and we were asked you to find the y value when x is -2, and we can just go to a calculator. And since everybody has Desmos at home, at least the internet, what you can do is type into Desmos a y equals. And if you hit the division sign, you can actually create this equation. I already forgot what the values were, though. Let me go back to it. X squared plus x minus 6. Over x squared minus 4. And now this graphing calculator will show you the graph. Unfortunately, it does not show you the hole in the graph. But if you were to click on it, you can then see the hole. So I'm not sure why this calculator does what it does. But the reason why I'm showing you this is you can actually look and convert this to a table, and you can actually quickly get the answers that when x is -2, this is undefined. And I think it's not letting me. If there's a way to change this to a fraction, I don't know how to do that. But back on we can quickly then go back and we can answer this question that when x is -2, this is undefined. And when x is -1, going back to the x is -1, the y value was 2. Otherwise, what you can do is plug in -1 squared minus 1 minus 6. So if you did that, you would get -6 over -1 squared. It's 1 minus 4 is -3, and you can double check that negative over negative is positive. 6 divided by 3 is 2. But maybe more specifically, if we were to look at this problem, and if we plugged in -2 in for all these x's, we would get 4 minus 2 is 2, minus 6, we would get -4 divided by 4 minus 4 is 0. And think about why this answer is undefined. What's the rule within math that makes something undefined? We cannot divide by 0. So what I'm trying to get at is that there's a reason why this is a defined value, because we can divide things as long as we're not dividing by 0. So if I go back to, I should have done this in orange now I'm thinking about it. What makes negative 2 be an issue is what would we be dividing by? We'd be dividing by 0. Why is there a hole at x equals 2? Well, we'd be dividing by 0. So what conclusions can you make? Your denominator cannot equal 0. And I hope this makes sense. If it doesn't, I get it. Every year I teach it, no matter how good I feel leaving the classroom, students forget or still don't understand that the denominator cannot equal 0. I may quickly, or just change colors, I shouldn't say quickly, because this might end up being a 3-video lesson, which is fine. And if I were to ask you to do this next one, well, g of negative 4 means to do the square root of 5 minus negative 4. So that's the square root of 9, which equals 3. Okay, that's good. All right, but now if I were to plug in 9 in for x, now I'd be trying to do 5 minus 9, which is the square root of negative 4. And if we go back to our graph, this is our graph, by the way, and when I got negative 4, my y value was 3, so that checked out. But it's undefined once I get to x equals 9. There's no graph to the right of x equals 5. And what's the issue? We cannot square root a negative. That's why this is an undefined answer. So what conclusion can you make? I'm going to write it this way. Now remember from an earlier video, and if I forgot to say it in an earlier video, let me explain it right now, is what's under the square root is called the argument. You might hear me say that a few times. Some people will call it the radicand. That would probably be a better statement here, but a lot of people forget that that's called a radicand, and they're familiar with the argument. I'm sorry about the bells. They do not turn the bells off. I'm just sorry about it. So if we cannot square root a negative, it makes sense then that the argument must be set greater than or equal to 0, and then solve it to find your domain. And maybe I should have wrote that earlier with this one. And solve. And we'll get practice problems with it. And so as we look at the last one, the cube root, I kind of gave the answer away for you, because if you plug in negative 11 in for these values, we'd be cube rooting negative 11 plus 3 is equal to the cube root of negative 8. And it sounds like you guys are familiar with your calculators already, that you can cube root negative, and that answer is negative 2. Basically what it's saying is, what number times itself 3 times gives you negative 8? Well, negative 2 times negative 2 times negative 2. You have 3 negatives, so it stays negative. So it's okay. Same thing with 5 plugging in. The cube root of 5 plus 3 is the same thing as the cube root of 8, which is 2. So basically, long story short, there are no issues with cube root. The domain will be all reals no matter what. That's why if I scroll back up and look at this, we have arrowheads going in both directions. The range is also all reals from negative infinity to infinity. I don't think there's anything else I want to touch base on that. So maybe I'll just do a few more problems and see if you can get this. May I just work through rational functions and then stop after that. And I think I messed up your pages when I reprinted this. So do not believe that page 46 matches with this, but it's the very next page. Anyway, so if we are trying to determine the domain of a rational function, it's basically saying the denominator, the way this is written is the function is a function over a function, cannot equal 0. And then you rewrite it in interval notation. So let me give you this. We actually can ignore the numerator, It's not very often you can just ignore something in math, but in this case we can. So x minus 3 and x minus 1 cannot equal 0. So it's basically the zero product property, and I'm not sure if you're familiar with, I'm sure you are familiar with it, but maybe your teacher hasn't said it, called it the zero product property before, is the only way to equal 0 is if this piece equals 0, and because it's not equal to, we just say not equal to, or the right piece equals 0. Because if this thing is 0, I don't care what this is, because 0 times anything equals 0. And vice versa, if this thing is 0, I don't care what this is, because anything times 0 is 0. So now all you have to do is add 3 over. Well, 0 plus 3 is 3. Add 1 over. 0 plus 1 is 1. I'm sure you remember that if these are your factors, then your solution is the opposite. Now, here's the thing with interval notation, is you always go least to greatest. So if I'm writing this as interval notation and all I want to do is say that these answers cannot happen, then I would say from negative infinity to 1, because 1 is smaller than 3, and then union 1 to 3, and then union 3 to infinity. If you do this in the wrong order, it does make the statement false, because if you say all values from negative infinity to 3, you're including 1, because 1 is smaller than 3. And then it wouldn't make sense to say 3 to 1, because there's no numbers bigger than 3 but smaller than 1. And then 1 to infinity, I hope you're recognizing why that would be wrong. So let me change colors and explain the next one. Again, you can ignore the numerator. I hope you're good at factoring. That's why they make you do it a ton in Algebra 2. This is what's called a difference of squares. We call it a difference of squares because it's a subtraction problem. That's the word we use for difference. Squares because 3 squared is 9. X times x is x squared. I guess I should have said it that way. So we write it as x minus 3, x plus 3. Sorry. It's just me making a mistake. And using the zero product property, we could say x cannot equal plus or minus 3. Some of you may solve this a little bit differently, and I don't mind. So our solution for the interval notation, least to greatest. All right, and then this next one, again, ignore the numerator. And I believe I'll teach this the same way as your Algebra 2 teacher, where they do the AC method. So 2 times negative 3 is negative 6. In the future, you might not see me factor this way. And then factors of negative 6 that add to be negative 5 would be negative 6 plus 1. So then rewrite the problem as 2x squared minus 6x plus 1x minus 3. And then you can group, factor by grouping. So greatest common factor there is 2x, x minus 3. There's nothing common there, so just write plus 1, x minus 3. So then you can write the x minus 3 once. And then in your other set of parentheses are the leftovers. That's how I call it, the 2x plus 1. Now remember, multiplication is commutative, so you may have learned putting x minus 3 over here and 2x plus 1 in front. But the point I'm trying to get at, and I'm trying to hurry because I'm almost out of time with my timer, double check my math, least to greatest. And I apologize, I'm going fast. And I will see you in the next video.